All right, let's look at week 14 examples. Okay, so Consumer Reports uses a survey of readers to obtain customer satisfaction ratings for the nation's largest retailers. Each survey respondent is asked to rate a specified retailer in terms of 6 factors. We have the quality of products, selection, value, checkout efficiency, service, and store layout. An overall satisfaction score summarizes the rating for each respondent with 100, meaning the respondent is completely satisfied in terms of all 6 factors, and the sample data representative of independent samples of Target and Walmart customers are shown below. So for Target, we have N being 25 and the mean being 79. For Walmart, we have the number being 30 respondents and the mean being 71. So we're supposed to formulate the null and alternative hypotheses to test whether there is a difference between the population mean customer satisfaction scores for the two retailers. Then we're supposed to assume that the experience with the Consumer Report Satisfaction Rating Scale indicates that a population standard deviation of 12 is a reasonable assumption for both retailers. Conduct the hypothesis test and report the p-value. At a 0.05 level of significance, what is your conclusion? And finally, which retailer, if either, appeared to have the greater customer satisfaction? Provide a 95% confidence interval for the difference between the population mean customer satisfaction scores for the two retailers. All right, so here the key is we want to see if there's a difference between them. So we're going to have basically the x1 minus x2. We want that to be 0. So, or in this case, we're using population. So how we're going to do it is we're going to label mu1 as the population satisfaction score for Target. Population 2 is going to be for Walmart. And so our hypothesis for the null is going to be mu1 minus mu2 is going to be 0. That's what we want to see. And the alternative is mu1 minus mu2 does not equal 0. Now, since it's equal to, here we have a two-tailed test, so there's a little bit of difference we have to do there. So then the next question was assume that the experience, and we need the population standard deviation of 12 and significance of 0.05. So what we have to do is first is we have to find the difference between the actual values. So 79 minus 71 is 8. Then we need to find the z-value. This is using the equation from the book. And so it's the mean difference minus d naught, which is going to be our 0 here. So basically 8 minus 0 over the square root of. Now the standard deviation they told us we could use was 12. And then we just have to use the numbers they gave us, 25 for Target and 30 for Walmart. And we do all that calculation, we get 2.46. So for this two-tailed test, we have two-tailed here, you have to multiply the p-value is 2 times upper tail. So the upper tail is when we find that 2.46. And so really when you find that, you get this area, so you have to take 1 minus that to get that purple area here. And so that gives us 1 minus 0.9931. We have to take that times 2 again because it's a two-tailed test. So that gives us a p-value of 0.0138. Now our alpha was 0.05. Since the p-value is less than that, we're going to actually reject h naught and say that the mean difference is not equal to 0, or that the two scores differ for the two retailers. All right, so the next one was which retailer, if either, appears to have a greater customer satisfaction and provide the 95% confidence interval. Well, our confidence interval is just going to be our difference in means plus or minus our z, alpha 0.025, because we had a 0.05 divided by 2 is 0.025, and then times the square root, and then we just have this sigma squared over n1 plus sigma squared over the n2. Plug in all our values. So that's the 1.96. This is what 8, and then we simplify all of this, and basically we get 8 plus or minus 6.37. So that gives us the interval 1.63 to 14.37. So what this tells us is, since Target was mu1, and that's going to be the higher value in this case, that shows a higher population mean customer satisfaction score compared to Walmart, with the 95% confidence interval indicating that it really is positive and it's a greater than. So then the 8, which is the difference, indicates that Target has a higher score than the Walmart does. All right, so the next one, commercial real estate prices and rental rates suffered substantial declines in 2008 and 2009. These declines were particularly severe in Asia, annual lease rates in Tokyo, Hong Kong, and Singapore declined by 40% or more. Even with such large declines, annual lease rates in Asia were still higher than those in many cities in Europe. Annual lease rates for a sample of 30 commercial properties in Hong Kong showed a mean of 1114 per square meter with a standard deviation of 230. Annual lease rates for a sample of 40 commercial properties in Paris showed a mean lease rate of 989 per square meter with a standard deviation of 195. On the basis of the sample results, can we conclude that the mean annual lease rate is higher in Hong Kong than in Paris? Develop appropriate null and alternative hypotheses. Use alpha equals 0.01. What is your conclusion? All right, so can we conclude that the mean lease rate is higher in Hong Kong than Paris? So we're gonna have to set maybe mu1 equal to Hong Kong and mu2 equal to the Paris, and then we want to take the mu1 minus a mu2 less than or equal to 0. And then our alternative, which is really what we're testing, is the Hong Kong higher than Paris, which is mu1 minus mu2 greater than 0. Now this is an upper-tailed test. All right, so first let's find the difference in the actual means. So we just take 1114 minus 989, and we get $125 per square meter difference. Now we have to find the t-value because we don't know the population standard deviations here, so we're going to use t's. So we have the difference 125 minus the 0 because we want to see if it's different than 0, if there's any difference, and divided by, now we have to use the sample standard deviation, so the 230 over the sample size n of n1 equal 30, and plus the 195 squared, which is the S2, and divided by the sample size of 40, and we come up with 2.40. Now this is equation 10.6 in our book. Now equation 10.7 in our book says we need to find the degrees of freedom. So we have to use this huge long equation, and basically we plug in all the values here, and again they're all simple. We know the standard deviations, the numbers, and that's really all we need. And you plug all that in your calculator, you get 56.5, so we're going to use 56 degrees of freedom. Now, using the t-table, our p-value is going to be between 0.005 and 0.01. And if we actually use the online calculator, we can find that is 0.0099. Now, even if we don't use that, since it's between 0.005 and 0.01, it has to be between them. It can't be equal to that 0.01. That's going to mean that it's going to be smaller than 0.01, so that's going to be the p-value is less than or equal to 0.01. So that means we're going to reject our H0, indicating that the Hong Kong rate is higher than Paris. Okay, so again, even if we didn't find this exact p-value, since we know that it's between there, it might be 0.002 or even 0.009. That's in between, and that either any of those values are going to be less than or equal to that 0.01. Okay, so then that means we reject. All right, Bank of America's consumer spending survey collected the data on annual credit card charges in 7 different categories of expenditures: transportation, groceries, dining out, household expenses, home furnishings, apparel, and entertainment. Using data from a sample of 42 credit card accounts, assume that each account was used to identify the annual credit card charges for groceries, which is going to be our population 1, and the annual credit card charges for dining out, which is population 2. And so that'll be your mu1, mu2. And using the difference data, the sample mean difference was d bar is equal to 850. So we're actually already subtracting it and giving us the d bar. And the sample standard deviation was SD, which was 1123. Now we're going to formulate the null and alternative hypothesis to test for no difference, so equals 0, between the population mean credit card charges for groceries and the population mean credit card charges for dining out. Then we're going to use a 0.05 level of significance. And can you conclude that the population means differ? What is the p-value? And then finally, which category, groceries or dining out, has a higher population mean annual credit card charge? And what is the point estimate of the difference between the population means? And what is the 95% confidence interval estimate of the difference between the population's means? All right, so let's go ahead and find our hypothesis test. So again, like I said, mu1 is going to be the population mean for the groceries, mean grocery expenditures. Mu2 is the population for the dining out, and they gave us already that the d bar is equal to 850. So what we're going to use, use, instead of the mu1 minus mu2, we're going to use just the mu difference is equal to 0, or the mu difference is not equal to 0 for our null and alternative hypothesis. And again, two-tailed test, so that's going to be important here in a little bit. So that's our hypothesis test we're going to look at. Now, basically, we're just going to be going through and testing it. So we don't have actually population standard deviation, so we have to use the t-test. So we're going to do our d-bar, which they gave us was 850, minus mu d, which is 0, over the standard deviation, which they said was 1123, and there was 42 for the sample size. That comes out 4.91. Now, degrees of freedom was 42 minus 1 is 41. And so if we look in our table on degrees of freedom of 41, we see that 2.701 is the most far right value. And that's going to be in the 0.005 column, or smaller. And since it's much, much larger than that, therefore our value on the top is going to be much, much smaller than a 0.005. And even if you multiply a much, much smaller value times 2, that's going to be really, really small. So we'll assume 0. But in any case, it's less than the 0.05. So we're going to reject H0, and we conclude that there is a difference between the annual population mean expenditures for groceries and for dining out. Now, the last one, it had asked for which category has a higher population credit card charge, what is the point estimate difference, and then the confidence interval. And so what we do is we're going to just use our equation here. Plug in d-bar, which we know is the 850, t of 0.025. If we go to our table, degrees of freedom of 41, that's going to be 2.020 for the 0.025 column. Our standard deviation, our n, that becomes 850 plus or minus 350, so that's 500 to 1200, and that's going to be our confidence interval, upper and lower limits here. Okay. What about this one? Chicago O'Hare and Atlanta Hartsfield-Jackson are the two busiest airports in the United States. The congestion often leads to delayed flight arrivals as well as delayed flight departures. The Bureau of Transportation tracks the on-time and delayed performance at major airports. A flight is considered delayed if it is more than 15 minutes behind schedule. The following sample data show the delayed departures of Chicago O'Hare and Atlanta Hartsfield-Jackson airports. So for flights, there's 900 flights at Chicago, 1,200 for Atlanta, and for delayed departures, 252 for Chicago and 312 for Atlanta. So part A, state the hypotheses that can be used to determine whether the population proportions, basically P1 and P2, of delayed departures differ at these two airports. And then what is the point estimate of the proportion of flights that have delayed departures at Chicago O'Hare? We'll call that P1 bar. And what is the point estimate of the proportion of flights that have delayed departures at Atlanta? That's going to be P2 bar. And then what is the p-value for the hypothesis test, and what is our conclusion? All right, so our hypothesis P1, like I said, is going to be the population proportion of delayed departures at Chicago, and P2 is going to be for Atlanta. And we want to see if the difference is different than 0. So P1 minus P2 is going to be equal to 0 for the null, and P1 minus P2 is not equal to 0 for the alternative. Now, our point estimates, we're just going to take 252 divided by 900 and 312 divided by 1200 for the appropriate values here for the P1 and P2, so 0.28 and 0.26. All right, so those were the easy calculations. Now for D, we need to find P bar, and so that's going to be N1 times P1 bar plus N2 times P2 bar, all over N1 plus N2. Now, if you remember here, that's just going to be basically this number times 900. Well, that number times 900 is just 252, and this number times 1200 is just 312, so that's why it's 252 plus 312 over basically our number is 900 and 1200, so that's 0.2686. So that's what we're going to use for P bar, but we already have our P1 bar and P2 bar. That was here and here, so we have 0.28 minus 0.26 divided by the 0.2686 times 1 minus 0.2686. And then the 1 over 900 plus 1 over 1200, all that put together, and we get 1.02 for our Z. It's two-tailed, so we have to take 2 times. And if we look that up in the table, it's 0.8 461, and we want what's above it, not below, so we have to take 1 minus that value, and 2 times all that gives us 0.3078. That's greater than pretty much any alpha value you can imagine, so we're going to not reject H naught. Okay, so we cannot conclude that there is a difference between the proportion of delayed departures at the two airports. So when it doesn't actually give you an alpha value in our question here, you kind of have to think about what does it tell us then. So that number is going to be pretty much larger than any of the alpha values, and therefore we're not going to reject our H naught, and so that's why we can make that conclusion. I hope these help again this week.